Hi guys, welcome to the channel Understanding.Concepts.Of.Physics. In case you haven't subscribed to my channel yet, you please go ahead and subscribe the channel and to follow more videos. We are on kinetic theory of gases as of now. We are trying to understand kinetic theory of gases in much detail. We have finished off the theoretical part. You can go through the videos before, and right now we are on the numerical section. So today we are going to do two numericals, 1 and 2, both on kinetic energy of gas and kinetic energy of gas per unit mole, per unit molecule, all this stuff. So let's get quickly started. So this first question, pretty easy, very short answer. You can pause the video and just go through the question. Okay, so 5 liter of gas, liter is a unit of volume, so this is volume. And it is S.T.P. S.T.P stands for temperature 0 degrees Celsius and pressure should be 1 atmosphere. Atmosphere is not an SI unit, we need to convert that. Fortunately, they have given us the value of our pressure, so not a worry. So I'll represent this data in tabular form. Volume is given as 5 liters. Now liter is not an SI unit, so 1 liter, the conversion factor is 1 liter is 10 raised to minus 3 meter cube. So this is the conversion factor between a liter and a meter cube. So I have multiplied this 10 raised to minus 3 to 5 so that I get from liter to I get meter cube. Pressure is given to us, temperature is 0 degrees Celsius, that is 273 Kelvin, and that is at S.T.P. Asked is kinetic energy of gas. Now this is one of the formulas which we have derived in previous videos. In case you haven't gone through those videos, I would request you to go please go and look at those videos where I have derived this equation 3 by 2 PV. So I'll put the value of P, I'll put the value of V and solve it, and I'll get this value. Okay, now just comment me in the section if you are not able to solve this question, the solving part. If you are not so mathematically inclined, then you can just let me know. I would elaborate this part in some other way. Then so I got the answer as 7.598. I've just rounded this number to fourth digit, and this is 10 raised to 3, and because it's a kinetic energy, the unit is joule. And because your answer should be between 0.5 and 5, 0.5 and 5, I have just moved this point over here, so that's 0.75, so I've increased 1 power 10 raised to 4. Now if you are not so mathematically inclined and your board does not require such high standards of converting it into proper significant digits and order of magnitude, you can stay put till here and you will get almost full marks for your answer. But if your board demands for significant figures and order of magnitude, I would suggest you go for this answer. Okay, so this is one. Let's go to the second question. Second question is a bit lengthy, not hard, but it's kind of lot of 3 things has to be found out. Pause the video and go through the question. Okay, so you are supposed to find out the average molecular kinetic energy, that is per kilomole, per kg and per molecule. Okay, so there are 3 things to be found out. Oxygen, it's an oxygen gas, it's 127 degrees Celsius and the molecular weight is 32, value of R is given, value of Avogadro's number is given. So let's see. So I have written that data in tabular form. The gas is oxygen, temperature is 127, add 127 to 273, you get 400 Kelvin. Molar mass is 32, which is given. Universal gas constant is 8.314, but they have given 8.31, so we are using this value. Avogadro's number again 6.022, but they have given single 2, so we'll be using this value. And we are supposed to find out kinetic energy per kilomole, kinetic energy per kg and kinetic energy per molecule. So let's go ahead. Again, kinetic energy per mole, this is the fixed formula we have used here, but I have derived this formula in previous videos. If you haven't been following this, then I would request to go back and see how it is derived. Once you know how it is derived, you will never try to remember this formula. You will always know how it has to be done. Now R is known, T is known. I have substituted the value of R, I have substituted the value of T. So this is 400, this is 8.31. I cancel this, 2 ones are, 2 200s are, and when you multiply this to everything, you get 4986 joules joules per mole. Now why this mole is because this is the kinetic energy per mole, so that's why it is divided by mole. Okay, so this is 4986. Now but then the problem is, if you see this, there is a mole here, and what you are supposed to find out is by using kilomole. So I am just trying to manipulate this mathematically. I have multiplied by 10 raised to 3 and I have divided by 10 raised to 3. Now this 10 raised to 3 is nothing but a kilo. So this 10 raised to 3 I am right, mole is written as kilomole, and this 10 raised to 3 remains as it is, and also I have shifted the point over here. So in case you have not been following, just pay attention here. 4986 into 10 raised to 3 upon 10 raised to 3. Now this 10 raised to 3 goes into kilomole. So you will never look this 10 raised to 3 if you are writing kilomole. So I have written, in place of mole I have written as kilomole. Next, this 4986 into 10 raised to 3, the point is here. So if I shift the point over here, I will get 4.986 into 10 raised to 3, and this 10 raised to 3 is as it is. This 10 raised to 3 is as it is. So because I have shifted the point, I get this 10 raised to 3. Now 4.986 into 10 raised to 3 into 10 raised to 3 is 10 raised to 6. So that's why I get 10 raised to 6. Now again, if you are not so mathematically inclined and if your board does not require these stuffs, then you can stay put till this answer, and yes, definitely you're supposed to convert that in kilojoules. But if you do not convert it to 3 digits, so 4 digit is fine, in case if you are not your board is not demanding such a perfect calculations. Okay, so this is what 4.99 10 raised to 6 joules per kilomole is. Now we go to the second question, that is kinetic energy per kg. So kinetic energy per kg is 3 by 2 RT by m0. Again I would say go back to the videos to find out this formula. R is given, T is given, m0 is given, R is substituted, T and m0 is substituted. Now pay attention that 32 is in grams and they have asked in kgs. So I will convert this here itself, 32 into 10 raised to minus 3. So this will become in kg. That's why this 10 raised to minus 3 comes in. Now if you solve this part, you will get 155.8 into 10 raised to 3. I have made that into 3 digits, so 1.56 because this is rounding off, and the points are shifted from this point to this point. So there is a 10 raised to 2 over here, and this is 10 raised to 3. So that becomes 10 raised to 5 joules per kg. Joules per kg because it is per kg. The kinetic energy is per kg. Okay, so this is what it is. I mean the second part is this, and now third, kinetic energy per molecule. This is the formula, RT by Na, that is Avogadro's number. Now R is given to us, T is given to us, and Avogadro's number is given to us. So these stuffs are put, and if you calculate that value, then I get this value, 8.28 into 10 raised to minus 3 joules per molecule, because the energy is kinetic energy per molecule. Now it totally depends on your board, which board you are following. In case if you are following some international boards, you will be provided with calculators, and this would be a piece of cake. Just punch in the calculator and you land up with this answer. If you are not from international boards, if you are from some regular boards, then definitely this, either you are supposed to solve this manually by cancelling to 1za to 200za and so on and so forth, or you can apply logarithms. Now just let me know in case if you are finding this part difficult, how to solve this. I would always try to make it easier in my coming videos. Okay, so please do comment, subscribe to the channel in case you haven't done it. Thank you so much for watching. Hope to see you in my next video tomorrow. Thank you so much. Bye.